All right, now after watching video number 1 on 7.5 for isosceles trapezoids and trapezoids and kites, we should be able to use those facts to find the missing information. So on the first example, we have what's called a keystone, and it keeps an arch from collapsing, and this architecture is just amazing from Roman times. So this keystone, angle L is 85 degrees. Well, this is an isosceles trapezoid because we have one pair of parallel sides and we have one pair of congruent sides. The legs are congruent and KL and JM are parallel. So angle L is 85, so the base angles would have to be equal. So angle Angle K would be 85 degrees. Now, what would angle J and angle M be? Well, since we have parallel lines, we know these two are equal, and we also know that these two are supplementary. So 180 minus 85 is 95, right? So therefore, the measure of angle J and the measure of angle M are both 95 degrees. Another way of doing it would be to add 85 and 85, and we get 170. We know that we have a quadrilateral, and from the lesson previously, that has to add up to 360. So those two angles would add up to 190, and we know they're equal. So we could take 190 divided by 2 and get 95 degrees. So either way, they're both going to be 95. Okay, now kite. Find the measure of angle D in the kite shown. All right, so this looks like our sketch pad picture. This is 115 and 73. Remember, D and F are equal because they're the non-vertex angles. Well, it's a quadrilateral, so we know that equals 360. So 115 plus 73 is 188. So I can subtract 188 from 360, 35, that'd be 172. So those angles then would be half of 172. 172 divided by 2 would be 86 degrees, each of those. Okay, if I go too fast, remember, just pause it. Then it says in a kite, the measures of the angles are 3x, 75, 90, and 120. Find the value of x. What are the measures of the angles that are congruent? Okay, so I'm going to draw me a kite. We know that one is 90. Ooh, we got a 90 degree in there somewhere. So let's see. I'm assuming then that's 90. And let's see. 3x, 90, 3x, 75, and 120. I mean, it may not look like that. It doesn't really matter. The important thing is here, what does the kite add up to? Well, the kite is 360. So we're going to add those up and equal 360. So 75 plus 90 plus 120. 75 plus 90 plus 120 is 285. Just like I thought it was. Equals 360. You're going to subtract 285. 3x equals 75. Divide by 3. And x is 25. So we did draw it correctly, because that's going to be 75 and 75. So it asks, what are the measures of the angles that are congruent? Well, that's got to be this angle and this angle. So they're both 75, because 3x, 3 times 25, is 75. Okay, now it wants to know, what is the most specific name for quadrilateral ABCD? Okay. Well, it looks like a square, does it not? But is it? Well, let's see. It gives us that the diagonal, this is equal to this, and this is equal to this, but it doesn't mean that they're all equal, because they're not, because there's one tick mark and two tick marks. So diagonals do not bisect each other in kites or trapezoids, so it can't be that. So it's either got to be a parallelogram, square, rhombus, etc. And then what's the most specific name? Well, I know a lot of you want to say square. But guys, if it's a square, then all those sides are equal and all those parts of the diagonals are equal. But that's not what it says. It also does not say that it's definitely not a rectangle either. Because if it was, then this would have one tick mark, this would have two, and so on. Those would have to add up to be equal, but they can't add up to be equal, like in a rectangle. So it looks to me like this must be a plain old parallelogram, right? Because we don't know anything else about the angles. We don't know anything else about the sides. We can't assume anything. We can't say, but it looks like it. We can't do that. So I think it's just a plain old parallelogram. Now it says, give the most specific name for the quadrilateral, explain your reasoning. Okay, look at number 8. 50, 50, 51, 51. So opposite sides aren't equal, but consecutive sides are. So that's a kite. Funny looking kite, but it's a kite. Okay, number 9. The diagonals are not bisected, therefore it can't be anything of a parallelogram. It can't be isosceles, can it? So this is a plain old trapezoid. It's a plain old trapezoid. Okay, number 10. We have opposite sides equal. We have this is equal to 9, but we don't know if that's equal to 9. This diagonal is bisected, but this one is not. Again, we don't know parallelism anywhere. If I had to guess, the only thing that could be is a trapezoid. That would be my guess. That's kind of fun. Okay, that completes our exercises, our problems, practice problems. Please consult the modules to